Right. So our next presenter gave a lightning talk at last year's Open Programming Miniconf where he demonstrated embedding CPython in a browser using a tool called Emscripten. And this for me was a sign of the promise of what JavaScript could actually end up doing. He's going to give a talk about languages that target JavaScript. Please make welcome Brian McKenna.
Thank you. So ALTJS is a term for languages that compile to JavaScript, and it's become a bit of a community, and there's a lot of languages that have come out recently that compile to JavaScript. So I'm going to try and convince you all that JavaScript sucks. I don't think that'll take too long. Then I'll talk about a couple of options that we've got already, and then I'll finish up about how you could try and make your own better JavaScript. So I'm Brian McKenna. I work at Atlassian. So for the Australians here, probably know Atlassian. We make Jira and Confluence and a couple other tools. I work on On-Demand, which is a hosted version. And all our products are pretty much Java. So I'm hired as a Java developer, but I find that a bit offensive. So just call me a graduate developer. Because I've been doing Java for that long. I've been doing JavaScript since I was 12. Mostly as a hobby. I started off with DHTML type things that followed cursor, so really dodgy stuff with JavaScript. So I love it, but it also upsets me. Why? Because there's boilerplate. So for example here, why do we need var? Why do we need function? Why do we need return? This all could be figured out. It's too tolerant for me. If you leave off a var, it goes to global. That's ridiculous. And there was a blog post a little while ago saying that their launch of a startup was ruined because they kept assigning to global scope and there was more connections coming in and they kept overriding each other and then it became corrupt and then their startup just crashed and they had a ruined launch. JavaScript's a bit too complex, so new. When do you use it? It depends on the implementation. It's also dangerous. 1 plus true equals 2 and 2 equals the string 2. It shouldn't. I think it shouldn't allow that. So let's ask Crockford, the Chuck Norris of JavaScript. Why do you like JavaScript so much? It's everywhere. It's got functions. It's got objects. He also said he likes loose typing, but I disagree with that, so I left it off. So how can we move it forward? And he said, we need to make it simpler, we need to make it safer. And we also need to make new languages. Awesome! The Chuck Norris of JavaScript is saying that we need to make new languages. So we need a JavaScript, but without the JavaScript. I mean, JavaScript is the only thing that runs everywhere at the moment. Java was meant to be that, it's not. JavaScript is the only thing that runs everywhere. So Josh Peak is a GitHub employee, and he went to a conference recently, I think it was JSConf in Europe, and he said that JS compilers, like languages that compile to JavaScript, are the future, and using regular JavaScript is like going to be not using a framework. So imagine not using jQuery for most of your stuff. But that's what it's going to be. So there's a heap of options. I maintain a list of them on altjs.org, and there's a lot. But I'm going to talk about 4 of them. And they are CoffeeScript, ClojureScript, Dart, and probably one that you haven't heard of, which is Roy. So CoffeeScript, its motto is, it's just JavaScript. That's because it's mostly syntax. Here's me, and that's the JavaScript. Easy. Here's a function. It takes a verb, it takes a noun, it's got a default argument. That's something that would take a little bit of code in JavaScript. You'll see on the next slide. And we're just calling it. And that's what it becomes. So it's expanded a lot of the idioms that you put into JavaScript and turned it into something that's pretty safe. Here's the scoping problem that I showed a bit earlier. So, you know, if you leave off the var, it'll assign to global scope. Here it will figure it out. So it sees that inner hasn't been used yet, so it's going to make that into it's going to make it local to the f function, and then it's going to make it global later on for inner. So you can see that it does var for the inside the function, and does all the safe ones on the outside as well. So it's a bit smarter than just JavaScript. And here's a function. It's got splats, which is like an array, passing an array to a function or doing apply on it. So this is the apply. So we're taking this array and we're passing them as arguments, each element separately. And that's the JavaScript it becomes. So it's starting to get a little bit, so it's gone from that to that, so it's exploded a lot. So it's using the arguments thing that's built into JavaScript, so you'd have to do this manually, you'd have to slice it manually. You'd have to index it or something. Up here, I don't know what CoffeeScript's doing there. It's just trying to get the slice out so I can call it here. I don't really know. But anyway, it's exploded to a lot of JavaScript that you would have had to write manually, at least some of it. It's got ranges, so that'll just explode to the literal JavaScript numbers. Slicing, so you don't have to call the .slice operator. And it's got comprehensions. So we're taking an array, and for each one in that, we're applying the square function on it. So that's pretty much directly from Python or Haskell or something. And that turns it into a for loop. So you'd write that usually, unless you're using something like underscore. So it's pretty cool, but it's nothing too advanced, right? It's not revolutionary. ClojureScript. It's a completely different language. It's Clojure, but compiling to JavaScript. So Rich Hickey, the creator of Clojure, said that JavaScript is not robust. And when asked, what do you mean by that? He said that writing robust JavaScript programs is possible, but it requires a lot of discipline, it requires a lot of convention. So, we need to build this into the language so that we don't have different people doing different things with a language that's so flexible. So he said Clojure rocks and JavaScript reaches. So coming from Clojure, it's got an awesome library. It's immutable by default. It's got good laziness in its library. It has built-in modules using Google Clojure and macros, which is the real thing about being a Lisp. People say that JavaScript's a Lisp, but when you see macros, you go, it's not a Lisp. So that's a bit confusing because Clojure is built on top of Clojure. Horrible naming. But the bottom one is Google Clojure, which is the module support. So a while ago, I wrote a blog post called Escaping Callback Hell with ClojureScript. Everyone know what callback hell is in JavaScript? Okay, one person. So callback hell is when you're writing Node.js and you've got heaps of nested function calls because everything's asynchronous. So you've got heaps of nested function calls and your code just starts going out like a triangle where you're like wrapping it all up at the end and calling them all at the front. That is callback hell. So we're trying to get if the application has a /index, we go in, get a user from it. If there's an error, then we pass it through. And then we go to the database. Then we got the cursor, now we can go through, and then we can eventually send back a response. After all that, it just kind of makes it hard to read. So I wrote one macro, and it does a reduce on the Lisp expressions. So it goes through and it builds up a big nested function call. So you can write code like that. So each one of these, this is PN, which is I think print with a new line. Yes, print with a new line. So it'll print with a new line, print with a new line. It'll just pass it through each time. So we'll do it with a callback each time. So it takes a second in between each one. So that's pretty much the JavaScript that you'd have to write. Of course, ClojureScript, because it's compiled, it's not very smart, and it converts it into that ugly stuff. But it works. You can have this synchronous-looking code, and it converts into asynchronous code. So Dart. I've only got 2 slides for Dart, and that's because I don't like Dart. I like Google, but I don't like Dart. I really don't know what they've got a lot of smart people working on Dart, but Dart's pretty stupid to me. So I don't want it. I don't even want to mention it really. But everyone was going to ask me about it, so I'll put it in. So Roy is a language you probably haven't heard of, and that's because it's the language I've been making. And it's functional. So I really like Haskell. I like static types. So that's what I'm trying to bring to JavaScript. It's kind of in between ClojureScript and CoffeeScript. ClojureScript is its own language, because it's Clojure. CoffeeScript is pretty much JavaScript. Roy, I feel, is a little bit in between. It's not really its own language, because it's specifically targeting JavaScript, but it's not very close to JavaScript. So this is assigning a value. Everything's immutable in Roy. So 100 equals 100. Converts into that JavaScript. That's pretty simple. Static typing, structural typing. So structural typing is having types based on the properties that an object has. So if an object has property A, which is a number, then a subtype of that would be an A, which is a number, and a B, which is a number. So it's making subtypes, but without the nominal type system, so you don't have to give them names all the time. And it can infer all the properties on it. So you don't have to type out, this is a person. It will kind of infer that. Pattern matching from Haskell or OCaml or any type of functional language. Monad syntax, which I stole from Haskell. So you can do asynchronous callbacks in like a synchronous style, just like I showed you with the ClojureScript. And it's all immutable. So this is showing static typing. So up the top, if we try and do 40 plus 2, 40 is a string. In JavaScript, that'll print something. I'm not actually sure. I think it will cast the 2, or coerce the 2 to a string. So it'll be 402, or will it do it the other way around? I don't know. But in Roy, that's not going to compile. It's not going to give you any output. And you can be explicit in your type. So this is creating a function. X is a number. So if you try and pass a string to that, it's going to fail. And that's the JavaScript. So it doesn't have to put any type checks in at runtime or anything. It does it all statically. This is the structural typing. So we've got a property X and a property Y. Build up. So this is obj, which is coming from JavaScript. It assumes that you know what you're doing with JavaScript, which is probably not a nice idea, but it works most of the time. And if you actually put a literal in there, it'll say, okay, well, you've got an X and you've got a Y, that satisfies it. If you put something without the Y, it'll say, okay, that's broken, I'm not going to give you a program. And that's JavaScript. Again, no runtime type checks. This is an algebraic data type. So we've got something, some part of data, or we've got nothing. So it's kind of like having a null or something in your JavaScript. A lot of people use null as a sentinel value, but here we're encoding it in the type system. So we can pattern match on that. So if we've got a value, then we can extract the value out and return it. Otherwise, it's 0. So we pass in none, it'll give us 0. Pass in a value, it'll give us the value. And that's JavaScript. It does an instant self-check. It has to check at runtime. This is purely for readability, I guess. I thought that having an instant self-check would be a lot cleaner than church encoding everything and having a lot of structures in the JavaScript. I kind of feel like Roy should have readable output. So that's purely why I've got the instance of check. So make your own JavaScript language. All I used was JSON, which is a parser generator, and Node.js. So here's a grammar. So you define some Lexa rules. So you say if you see this regular expression, then return this token. If you see this, return that token. And then we've got a grammar, in Bacchus-Naur form. So if you see a number, wrap it up in a special collection that you write. So that's not a JavaScript number. That's a number that I've written that takes an argument. And the same for all your other data types or all your other expressions that you're going to accept. So here, this is a number. It takes a value, and I've encoded the visitor pattern. So whenever you call accept, if it's a number, it's going to go through and run that function on that number. And here's how you would use it. So you'd use the parser. Parser comes from JSON. You'd parse it. It'll give you back this as the syntax tree. Then you can do accept. Because it's a number, it's going to go through to the visit function. and then just log out the value. You've done a compiler for a number. Easy. Everyone asks me, is it hard to debug these ALTJS languages? Yes, it is. But it's getting a little bit better. We've got source map coming into, we'll be in Firefox 9. I think Firefox 9 came out a while ago, right?
Firefox 10.
Okay. I wrote this a while ago. So, yeah. So source map. Source map is a way of mapping from generated JavaScript back to the original source file. So you can say line 9 of this JavaScript map actually back to my line 4 of my ROI file. And then you can go into the JavaScript debugger eventually in Chrome and currently in Firefox, and you can map it backwards and say, okay, what was the actual source code, not the one that was generated. So that makes it a little bit nicer to debug because you can actually reason about what you wrote. Another question is, why not just make JavaScript better? Why don't I join a standards committee and try and push JavaScript forward? This is why. Internet Explorer 6 came out in 2001. Does anybody maintain any IE6 websites? One person? A couple people? Yeah? So 2001, we're stuck with technology from 2001. If I make JavaScript better tomorrow, I'm not going to see it for, what, 11 years?
If you're lucky.
If I'm lucky. So even Firefox 3.5, like, I mean, 2009, like, no matter how much I try and push JavaScript forward, as a standard, it's not going to be implemented and actually a de facto standard for a lot longer. So I feel like we shouldn't be limited by what JavaScript offers us. I feel like we should go ahead, make languages that compile into what we've got now, and then we'll be happy. So I'm maintaining this list of JavaScript languages at the top. We've got a Freenode channel that we talk about languages compiled to JavaScript, and we've got a Google group, and that's me. Thank you.
Cool. Questions?
Hi. Do you think there's any danger from these? I know CoffeeScript's certainly getting massively popular, for a whole generation of people not really knowing JavaScript fully, or do you think that matters if they don't?
I don't personally think that it matters too much. It's kind of like saying that the separation between C and assembly or anything like that, like you don't really have to know machine code to be a good C programmer these days. It helps, but you don't have to.
Anyone else?
How well do these new languages work with the existing libraries and stuff, like jQuery and all the rest of it?
Very varying. So we've got ClojureScript. It's kind of hard to actually use to use jQuery or something with ClojureScript. You have to modify it a lot, but it is possible. CoffeeScript, for example, it is just JavaScript. You can just call jQuery and it works fine. With Roy, it's a bit of a compromise. You lose static typing on it. But yeah, so each one, it really depends. Like for a lot of them, there's like a couple of languages that compile Haskell to JavaScript. In that, you're pretty much stuffed.
Cool. Anyone else? Great. Well, I hope after this talk nobody goes out and writes raw JavaScript again. Please thank Brian for his talk.